Hello everyone, I'm Jiayi Hu, and this is a project presentation for CNT6805, and my project name is Social Network Topology Analysis. Social network analysis is the process of investigating social structures by network and graph theories. It characterizes network structures in terms of nodes, individual actors, people or things within the network, and the ties, edges or links, relationships or interactions that connect them. Examples of social structures commonly visualized through social network analysis include social media networks, friendship and acquaintance networks, collaboration graphs, kinship, disease transmission, and sexual relationships. These networks are often visualized through social graphs in which nodes are represented as points and ties are represented as links. In this project, data is downloaded from SNAP. Stanford Network Analysis Platform is a general-purpose network analysis and graph mining library. SNAP collects many datasets of social networks, networks with ground truth, communities, communication networks, citation networks, collaboration networks, web graphs, and many other networks. In this project, we only focus on social networks. Snap provides several social networks like social circles from Facebook, Google+, and Twitter. I chose to analyze Facebook's social circle because it has modest scale. There are 4,039 nodes and 8,234 edges in this network. Basically, three kinds of features are need to be extracted from input data: degrees, clustering coefficient, and the path length. First, in the input file, each line has two columns. The first column is a node ID. The second is the node that this node points to. As a result, to analyze our network, first we have to construct an adjacency matrix, since there are many nodes and most of them are not connected. First, we can construct a sparse matrix, then turn into a full matrix. The adjacency matrix I get is shown in the right picture. In this undirected social network, degree means the number of edges that incident on a node. In this project, I calculate degree of each node and get distribution curve of degree. The left picture shows the degree distribution diagram of each node, and right picture shows probability distribution diagram of node degree. According to graph theory, clustering coefficient is a graph node aggregation degree coefficient. The evidence suggests that in a real network, especially in the specific network, because of the relatively high density points, nodes always tend to establish a set of strict organization relationships. In the real-world networks, this possibility is often then random setup a connection between two nodes of the average probability is bigger. This relationship can be quantified using clustering coefficients. Two definitions of clustering coefficient exist: the global and the local. The global clustering coefficient was designed to give an overall indexation of the clustering in the network, whereas the local gives an indexation of the imbalance of single nodes. This is the clustering coefficient I get of this Facebook social network. The average clustering coefficient is 0.228. I also use a Girvan-Neiman algorithm to find out community information of this social network. Since the whole network is too large, I built a subgraph of the first 100 nodes in the regional graph. In this calculation, I set number of modem as 5. The result of community analysis is shown in the right picture. I used Dijkstra algorithm to calculate the shortest path from one node to all the other. My program was will return a matrix with one row and 4039 columns that records the length of shortest path from the start node to every other. After I calculate all the shortest paths, I can calculate the diameter, which is the longest shortest path in the graph. We have to find the shortest path from every node in this graph to all others, and then we can calculate its diameter. The following pictures shows the code I used to calculate this diameter. This is the result I get. The diameter of this Facebook social network is 17. And thank you.